Hello guys, my name is Timothy Noah Joseph. In this lesson, I am going to teach you capacitors in parallel. There are two ways in which we can connect capacitors. The first is series connection and the second is parallel connection. So in this video, I am going to teach you the parallel connection of capacitors. I'm going to show you how to derive the formula and how to apply these formulas to solve related problem. So let's just begin without wasting much time. Okay, look at the diagram on the screen. On the screen here, we have two circuits, and then we have the first one here. The capacitors here are connected in parallel. You can see to a certain voltage here, and then here we can find the combined capacitance here, or the total capacitance in these circuits. Since we have capacitor 1 and capacitor 2 sharing the same voltage, so our combined capacitance or total capacitance, if you want to say total capacitance, so let's use total capacitance, is going to be C1 plus C2. So this is going to give us the combined capacitance in these circuits. And then we can also find the charge on each capacitor, the charge here and the charge in this capacitor as well, by using the simple equation that is Q1 will be equal to C1 multiplied by the potential difference or the voltage here. And then the same thing applicable to this, the charge stored on this capacitor is going to be Q2 equal to C2 multiplied by the voltage here. And then let's look at the second diagram, which is also an example of capacitors in parallel connection. So look at it, we have the capacitor 1, capacitor 2, capacitor 3 here, and then we can also find the combined capacitance. So the combined capacitance here in this one will be, so let's say the combined capacitance or total capacitance will be, let's say total equal to C1 plus C2 and then plus C3. So which means that we are having this, so which means 0.1 plus 0.2 and then plus 0.3. And then our total capacitance will be what? So we should have 0.6 microfarad. Yes, this is the combined capacitance here in this circuit. And then we can also find the charge on each capacitor. Since they share the same voltage, the potential difference here is 12. So by using the same equation, that is, we are going to say the charge stored in capacitor 1 will be this Q1. So let's say Q1 equal to C1 times the voltage, which means we are simply saying 0.1 times 12. And then we should have something like this, 0.1 times 12, we should have 1.2 microcoulomb. Then in the charge stored on this capacitor, so we apply the same equation, C2 times the potential difference, which is going to be 0.2 times this 12, and then we have the charge store should be 2.4 microcoulomb. And the same thing applicable to this, so let's put that here. We are going to have the same thing, so let's say the charge store in the capacitor 3 is C3 times the potential difference, and then we are going to have this C3 is 0.3 times 12. So we should have something like this, 0.3 times 12, we should have 3.6, yes, 3.6 microcoulombs. So you can see how to calculate the charge stored on each capacitor. So if you are asked to calculate the total charge stored in these circuits, we will just add Q1 plus Q2 and then plus Q3. That will give us the total charge stored in this circuit, or we just apply this simple equation by using Q1 equal to C times this the capacitance total capacitance times the potential difference 12. Total capacitance is 0.6, and then we just 0.6 times this, and then we are going to have the total charge stored in this circuit. Okay, all right. So this is how to uh, solve the problem involving capacitors in parallel. Let's take another example to solve for more understanding. Okay, so let's clean the screen and then we solve another problem. This is just an explanation. So, okay, so let's consider this example. A 3.0 volts battery is connected to a 4.0 microfarad capacitor and a 2.0 microfarad in parallel with each other. Calculate 1a, the combined capacitance of the capacitors, 2, the charge stored on each capacitor, and 3, the total charge stored. So take a look at the diagram. So we have these capacitors connected in parallel, 4.0 microfarad and then 2.0 microfarad, and we have they share the same potential difference, which is 3.0 volts. We are going to calculate what we are asked to calculate in this question. So here, the first one said the combined capacitance of the capacitors, which is very simple to calculate. So the first question, combined capacitance. So let's say this is capacitor 1. So let's say this is capacitor 1 and then this is capacitor 2. So we will just add the value. So which means capacitor combined capacitance is going to be capacitor 1 plus capacitor 2. And then we are having something like this 4.0 plus what? 2.0 microfarad, and then the total capacitance is going to be 6.0 microfarad. So this is how to calculate this. And then let's take the second question, which says the charge stored on each capacitor. So the charge stored on each capacitor, that is the second question. The charge stored on each capacitor will just be so we're going to say Q1 equal to C1 times V1. Yes, so let's take the charge. Let's find the charge stored in this capacitor 1 first. What do we have? Capacitor 1 is 4.0. So we are going to say our charge stored here will be 4.0 times the voltage, which is 3.0. And then we are having this as what? What do we have? 4.0 times 3.0. So we are having 12.0 microcoulomb. So this is the charge stored in capacitor 1, this capacitor. And then let's take the second one, which is capacitor 2. So we apply this. So we're going to have Q2 equal to C2 multiplied by V of potential difference. So and then we should have something like this. C2 is 2.0 times the potential difference, which is 3.0 volts, and then we should have 6.0 microcoulomb. So this is the charge stored in this in the second capacitor. So the last question says the total charge stored. The total charge stored can be given as so we can say total charge stored will be Q1 plus Q2, which means we are saying 12.0 plus 6.0, right? Okay, so and then we should have 18.0 microcoulomb. Or you can apply this equation, that is to find the total charge store by saying CV times V, which means the combined capacitance, which is 6.0 times the voltage, which is 3.0, and then you are still going to have 18.0 microcoulomb. So this is how to apply the equation or the formulas to solve capacitors in parallel problems. So this is where I'm going to stop in this video. In the next video, I am going to do a lesson on capacitors in series. Yes, please watch out for that lesson. But before I go, I would like to remind you that I have a channel for mathematics where I teach mathematics on YouTube. So if you're a lover of mathematics and you want to improve your mathematics skills and understanding, please search for Past Mathematics channel on YouTube. Past Mathematics channel. It is like this: Past Mathematics channel on YouTube. So don't mind the handwriting, mathematics channel on YouTube, and then watch the video. If you like the lessons, please subscribe to the channel. Thank you for taking your time to watch this lesson. Please comment, like the video, and if you have any questions, just write in the comments box. I'm going to answer your question. Goodbye for now.